Hi, welcome. Today we are going to see how to model this water supply project here by using EPANET 2.2. As you can see here, we have a water storage tank, and with this storage tank here supplies water in these 4 points. As a matter of fact, we are going to cover a lot. So if you don't know how to digitize or how to extract coordinates from Google Earth Pro, I have a full video explaining how to do such a process, and I'll make sure that I include that video in the description below. So we are going to take it from here. Okay, we are going to take it from here all the way to EPANET 2.2, as you can see here. Again, this one here is our storage tank, and this is our full network in EPANET 2.2. So we are going to take it from here. That being said, I'll see you in the next part of the video. Okay, so this is our coordinates. Okay, and as you can see here, we have in points, point number, northings, eastings, elevation, and the description. So this is the format that make sure that your data are in this format. Okay, before we proceed, we need to make sure that our coordinates are in format that is compatible with EPANET. Okay, compatible with EPANET. That is very important. Now we are going to take it from we are going to do it step by step, but if you want, I have a full video tutorial explaining all the software that are required, all the steps in details. So if by any chance you want, go back and watch that tutorial. I'll make sure that I include that the link to that video in the description below. So by starting, let's remove this title here, and we need to make sure that our data are saved in CSV. Okay, CSV. Let's give it a name, any name, points, WS, and format. Of course, you can use .txt, but for me and for this tutorial, I'm going to use CSV, delimited. Okay, and save. Okay, cancel. Okay, so my points, as you can see here in my folder, I have my points here, points ws.csv. So that is first step, and the next step is to make sure that we import our data into AutoCAD, so as we can convert it to DXF file format. So that being said, the step that we need to do is to go here, make sure that you have Civil 3D. That is very important, and again, we can use these points here and point creation tools. Okay, so from here, go here, import points. Remember, this is Civil 3D, very important, and we are going to import our coordinates here. So my folder was in desktop. Wait a bit, desktop tutorial, and points ws. Okay, sometimes it doesn't work, so I'm going to try again. So it happens sometimes it doesn't work, so just keep on trying, maybe it works just like me. So from here, what we need to do is to make sure that our coordinates are in points, just like this, PN EZD. That's very important. As you can see here, we have our sample data. Okay, so from here, click OK. And if by any chance after importing your data you don't see your data, please just click zoom to extent. Okay, and start scrolling the wheel until you see your points. So as you can see here, we have, this is our storage tank, this is junction, and this is delivery point. Again, this is delivery point, and this also is a delivery point. So after this, what we need to understand is that we need to have a total number of our coordinates. To me, the total number is 225. So it's depending on your points. So for me, it's 225. Now, what we need to do here is to make sure that our coordinates here are linked by line. As you can see here, they are not linked. Okay, we need to make sure that our coordinates, all of our coordinates, are linked by line, and this line between the points is going to act as water pipes in EPANET. So that is very important. As as I said, make sure that you know the total number of your points. And after that, then go here to create line by range. So to me is 125. So I'll click here 1 to 225. Then just click it and let AutoCAD draw the line for me. Okay. These points are going to act as pipes in EPANET, so that's very important. A bit. Okay, done. So click here escape, and after that we need to clean all the unrequired files. So from here I have this line, just delete, not required, and again this one, again delete, and also I think this one also need to delete. Okay, so here is our project: storage tank, junction, and delivery point. What we need to do next is to export, of course, to save as, export save as, I don't know the same, save as. So we need to save it in DXF file format. My tutorial folder is this one. I'll save it as DXF file format. I'll just put here WS. You can name whatever you want, whatever name that you want. So for me, I'll go with this one, and I'll save it as DXF. Going back to my tutorial folder, as you can see here, my tutorial folder, yeah, it is this one, WS DXF. So what next now is to make sure that we take this DXF file to EPACAD. Now EPACAD, what EPACAD does is to make sure that our DXF file format is converted to .inp. Remember, .inp is file format that works with EPANET. So from here, just click open. Okay, open. I'm going to my folder, file tutorial, this WS, just open. You will have these layers here. For me, it's layer number 0, possibly even for you, layer number 0. Next, and click finish. So I'll just give it a name, WS project, whatever project. Remember, file format is here is INP. That's very important. Give it a name, file format INP, then click save. Oh, that was too loud. Now we are done. Now what we have been doing here is to make sure that our coordinates, we take our coordinates from Excel file to DXF, then from DXF to INP by using EPACAD. Okay, so what next now is to open our EPANET software. So for me it is this one. Yeah, so here, this is my EPANET 2.0. So from here, just click file, of course, import, yeah, import network. Okay, so I'm going all the way to my desktop, to my folder location, which was tutorial. I remember it was in tutorial. Yes, tutorial, this one. And this is my file. Remember, EPANET works with INP. So from here, just click open. So this is my network. As you can see here, this, as we can go back here, this was a storage tank, and this is junction, although these are delivery points, as you can see here. So this is a storage tank. This is exactly what we have here. Now what we need to do from here is to make sure that all our points are linked. Okay, zoom extend. So before we do anything, just make sure that units are in format that you. So for me, I'll just go here to projects, project, then to project defaults. So from project default here, I'll go all the way to hydraulics here. As you can see here, flow, I prefer to use liters per second. Of course, this is in metric. If you prefer to work with empirical format, you can just click here, whatever you want. So for me, I'll work with liters per second, and head loss formula as in William, as usual. And next thing here, I think that's done. Liters per second, that's important. So from here, I think there's nothing I can change. ID level, again. So from here, I'll just do this. Then I will explain later on. So from here, just junction, then J dash reservoir, R dash. Of course, we don't have reservoir. So from tanks, I'll keep it as storage tank, ST dash. And pipes, I'll keep it as P, then dash. Pumps, PMP. Of course, we don't have pumps here. Valve as V. Done. Of course, you can work with this one. So for me, that's more than enough. Then click OK. So before you click OK, you can save it as default for all new projects. You can click here if you want to use that format that you set here. So for me, I just click OK. And the next one here, I will go in default preference. You can go here also in preferences to see if there is anything you can change. No. Okay, and again, right click option, and you can see here links. I'll just leave the way they are. Labels the way they are. Notion, I'll prefer to display node value and the link, again link value. Font size, of course, we can increase later. Symbol, flow arrow, field, you can change your reference. For me, I'll keep it field. Then okay. So from here we can start our way. Again, this is our storage tank, delivery point, delivery point, delivery point, and again this is delivery point. Now let's allocate our storage tank here. Our storage tank was in this junction. Okay, in this junction. Yeah, as you can see here, this junction and this one, they are not linked. Just zoom, just like that. I need to know the length of this pipe. Length here is 18, 15, okay, 18, 15. And elevation here was 17, 45.1 elevation. And again here, pipe length 13.86. I need to allocate my storage tank here. Okay, so zoom, then just delete all of this. I don't want them. Delete, and again here, delete. So we'll put here our storage tank. Now from here, just go to this point here, add tank. I'll put here my tank. So here is my water storage tank. Again here, we need to have pipe from here all the way to this junction, and again from storage tank to this junction here. As you can remember, this pipe here had like 18.15, so that was the length. From here, click OK. Again, this one 13.86. That again, that was the length, and this is our storage. Now storage tank here, we can put its properties. So from here, elevation was 17, 45.1. Initial level as far as this storage tank is concerned is 3 meter, and minimum level is 0.3. Maximum level the same, 3. Diameter 6.5 meters. Done. Okay, so the next thing we need to do here, our junction. Of course, this junction here, as you can see here, something is not correct. We need to rectify some stuffs here. Okay, take 14, 7, yeah. So again this, we need to make sure that all of these points here are linked with this one. Okay, so we need to know the length of this is 28, 23, and again this one is 36.42. Elevation here is 17, 14.9. That's very important. Now we need to remove this node so that we create new nodes from here. So remove this, remove, and again this one, you can remove it. So from here we create new links or new pipes. So this one, again we take it from here, so from here to here, done. And this one was 36.42, and again this one was 28.23. okay, so that's done. Now our pipes are well linked, and again another one from here. I think we are done. So all coordinates are linked, and all pipes here are well linked, no gaps between, so everything is perfect. Now what we need to do next is to assign demand. Demand in this area, at this point here, we need to assign demand, and again this point, and this, and this. Okay, so this is our storage tank, so we need to assign the demands. So the demand at this point here was 0.6 liters per second. Of course, it's not that much, 0.6. This is our base demand, 0.6. And again, another point was here. We need to again to assign 0.6. Another point was this. Again, 0.6. And this one here was 1.6. okay, so we are done. What next? Zoom X. So this is our tank. Again, this tank is supposed to supply 0.6, 0.6, and 0.6 here. So next, what we need to do after assigning, so as you can see here, our pipes here has a default size, which is 12, and even roughness here is 100. So for me, all of my pipes are in HDPE plastic pipes, and what we need to do here, zoom extend, so select everything, select all, and we need to group edit here. Now group edit, select pipes, go to roughness. From 100 we need to change it to 140, then click OK. Okay, so instead of changing one pipe to another, just click here, and again just click here, select group edit. Now the next thing here, we need to at least change the pipe diameter. 12 millimeter is very small, so let's start with 50 millimeter with internal diameter of 46. So throughout 50 millimeter with internal diameter of 36. Remember, diameter here we need to use the internal diameter. That's very important. Then click OK. Let's start with that one. Then let's run and see how our model is going to behave. Okay, so from here, just click run. Of course, everything is fine. As you can see here, now select elevation. Of course, as you know, we don't need elevation, so we need to select pressure. And again, we need to view velocity. Okay. As you can see here, pressure, we have this pressure here, and again velocity is that one. And so what we need to do next here, the pressure is 82, that is quite big. Okay, and at this point here again, flow is how much? As you can see here, we have 1 meter per second. It's not bad, but again, it's not that good. We can increase a little bit here, but there is no need. Let's see. Now at the end here we have like 50. Again, this here is 100, is a little big. So what we can do here, we can change pipe from this point here to this one. We can reduce and see how pressure is going to behave in this area here. Now from here, select the region. Let's start from here. Okay, from here let's go to this. So this region, we need to change the pipe diameter. Again, select group edit. So from here, select pipes and diameter. We need to take it from 50 millimeter pipes to 32 with internal diameter of 28. Okay, now pressure here is 102. Let's run again and see. Oops, we have negatives, so it's not good. We need to increase. I think. What we need to do here, we need to change back. I think this one is not working. Let's get back to, because as you can see here, velocity is quite big. Okay, velocity here is quite big. So let's take it from here. Let's increase it to 50 millimeter and see what's going to happen, because I think this one is not working perfectly for this. Okay, so from here let's increase, let's select region again, select it from here, I think, and again let's go back to group edit, select diameter, pipe diameter, not junction, pipes. Select diameter. Let's get back to 46. 50 is the internal diameter of 46. Okay. Now we are doing good. Yeah. But something that I don't like here is this pressure here is kind of big. You know, this pressure here is, to me, I think it is too big. 102 is too big, so we need to reduce it. Let's take it from here again, from this corner here all the way to we need to reduce these pipes here to at least 32 and see how pressure is going to behave in this area. So from here, select group edit again, take it from 50 pipes, again diameter, take it from 50, reduce it to 28 internal diameter, and let's run again and see. That's not good. Negative pressure again. Let's get back to 50 diameter. So let's take it back to 50 with internal diameter of 46. Okay, 46. Run. Yeah, I think we can take it, we can leave it the way it is. We can leave it the way it is, and let's look at flow. 0.9 flow here is 1.6 liters per second. 1.6. Okay, and again let's check here again. Let's check in this branch. This branch 56 with a flow of, our flow here is 0.6. Now we need to reduce again. Let's try to reduce this portion here and see if we can reduce the pressure. from 56 at least to 20, around there. From here, let's take it group edit. Let's work with pipes again all the way to diameter. Our diameter now, let's set it to 32 millimeter with internal diameter of 28. And let's run. Remember here our pressure is 57.64. Let's run again. So 56 at least, but again it's not that good, but at least, you know, this is a delivery point. This is the point where people consume more. So at least we need to make sure that pressure is a little bit small. That's the idea. Now let's again here, let's try to reduce some portion. Let's take it from here, at least this one, this portion again. Reduce pipes to 32. Group edit, then select pipes diameter again to 32 millimeter with internal diameter of 28. Click OK. From here, then run again. At least now we have 31. And again, let's try to reduce it again, at least to have 20 around there, 20 around something, 20. So select the region again. Okay. Now group edit, pipes diameter 28. Now the idea is to reduce pressure to a reasonable. As you can see here, now we have 20. We have 26. As you can see here, we have 25. Sorry, 25. Let's increase the font notion. So as you can see, font size 10. At least now, as you can see here, I don't know if this color is that good, but the pressure now is 25, which makes sense a little. So from this junction as well, we can do the same because the demand here is also 0.6. So we can reduce these pipes here at least to make sure that our pressure at the end point here is reasonable. As you can see here now, we have like 82 is a bit big. So we need to reduce these pipes here. Remember, when you reduce pipes, you increase head losses, and when you increase head losses, at the end you reduce the pressure. That's the idea. So from here, again, let's select region. So let's start from here and see what we are going to get. Select this area here, group edit, again, pipes and diameter, reduce it to 32 with internal diameter of 28. Okay, and let's try to run. Everything is perfect. So from 82 to 46, not that bad, but let's try again. Let's do it again. So from here, now this area here. Okay, so group edit again, pipes, select diameter and 28. Okay, again we are good. At least now, as you can see here, pressure is like 32. Now pressure here is 32, which is not bad, at least. 82 was very big. So from here, what we need to do next is in this branch here. What pressure here is 48. As you can see here, pressure is 48. Let's try to deal with it again a little bit. Now let's take this portion here. Let's reduce pipes in this portion. Again, select region. So from here up to here, all the way this region, we need to reduce pipes to, let's go to group edit, select pipes again to diameter 28 and see what we get. 18. Yeah, that's reasonable. So we'll leave it like that. But remember, this is just an introduction. You need to work with it, especially when it comes to pressure. And remember, again, we need to make sure that our system is within a certain value of velocity. So that being said, we have, let's go back to velocity. Again, you can see here velocity is 0.97. Again, in this area here, 0.9, and again this area here is also 0.9. So velocity is good. Now what we need to do, now as you can see here, our pressure here is a little bit small. As you can see here, we have 3 in this branch here. This branch, we have pressure here is a little bit small. So to increase pressure, what we need to do is to increase this, to increase the diameter of this pipe here. So again, the idea is the same. Take a region here. So from here, select this region. Okay, select this region. Let's increase pipe diameter here at least to 75 millimeter pipes with 75 with 49.9, sorry, 69.2. So this is a 2-inch, is 75 millimeter pipe with internal diameter of 39.2. Then select enter, select OK. Sorry, we need to make sure that here our pipes, again this one is 69.2. Unfortunately, they are not selected both. 69.2, and again here is 69.2, and this one, yeah, so this one is done. What we need to do again is this here, this part here. I think pipes, they are not, so select this part here. This part is 69.2 and this 69, but this point 69.2. And let's see if we remain with this 5 here. 5, I don't know, 3, it's a bit small, so we need to increase a little bit. At least now, at least not that bad. We have a reasonable pressure here. Yeah, at least that's what next. Yep, remove this, no preview. Okay. So this is our storage tank. Let's remove here pressures, and again let's remove here no display. So this is our system. As I said, this was a storage tank. Okay, and this is the point. Again, this is the delivery point. So what we tried to see here is to make sure that our system is maintained within a certain range of velocity, certain range of pressure, not too big, not too small. Okay, so that is the process that you need to go through. Just make sure that your velocity are within a certain range, and again pressures. So that being said, I think for now it is good. Now what we need to do is to produce a report. Again, report you can produce with several ways. So for me, I'll go here to reports, select no, just before that you can select here and look at nodes. So let's say nodes. Within nodes, we don't need quality and elevation. We want elevation, then select OK. So you can see all of your node here with pressures. Okay, so all of these are your nodes. Again, these are the pressure. Okay, so the next thing, again, you can do it with pipes as well to see how to see the velocity and all those stuff. So you can go here with networks, then select everything that you need to see from here. Okay, let's have a quick look here. Reaction, friction factor, I don't know, then diameter and length, then click OK. So you can see here, this is my velocity. Again, this is the flow. Okay, so that is it. So we need to produce a full report here. You can just go to full report, and from full report here, just go to desktop and tutorial. I'll save in your preferred folder. So for me, that is my folder. Just click OK. Just click save. From here, I will go to my folder, which is in design tutorial. Then select, my report was this. Then open with window, Microsoft Word, Microsoft Word. So let's see what we have here. So this is your full a full report. As you can see here, EPANET version 2.2, and these are the nodes. It's like 28 pages. You can see here diameter, length, every property you can get it from here. So that is the diameter. Again, if you go back, you go down here, you can see pressure and everything, head, okay, pressure, quality is 0 because we are not working with quality. Okay, pressure and everything. So that is it guys. And that being said, hopefully I'll catch you in the next video tutorial. Thanks.